Hi. In this video, we will solve an example for related rate problems. It's a word problem, and we will try to go step by step and solve it and complete the solution. Well, the example says the radius of a circular oil spill on a water body grows at rate of 5 meter per minute. So the radius grows 5 meter per minute. How fast the area of the spill grows when the radius is 100 meters. Well, we'll start with first identify the quantities involved. Well, for example, here we have a circular spill, and we have the area of the spill. And while we have radius of that, and everything else is around these two things. We have to choose variables for these guys. Let's choose A for the area, R for the radius. And what are the information, the given information? Write given information in terms of these variables. For example, we know that we are looking for the rate of change of the area when radius is 100 meter, and we know that the t or rate of change of the radius is 5 meter per minute. So these are all information given there. So that finishes our first step of modeling. Then we go ahead and write an equation. Find an equation. So this equation should relate the variable or variables. For example, here, while we have a circle and radius is r, we know that the area of circle is pi r squared. Well, that's the equation. Now you've done that and you see that modeling is done. What is the problem? So solve. So here the mathematical problem is ready now to be solved. Mathematical problem is what? It is, we have A equals to pi r squared. There's an equation for A and R, and we know that dr dt is 5 meter per minute, and we are looking for the rate of change of the area when r is 100. So this is completely mathematical. We don't need to know what is that where is that A coming from or R is coming from. These are just some variables and relates. So we start differentiating the equation. The equation here, well, with respect to what? With respect to time variable, which is t. So we have d dt of A and d dt of pi r squared. And remember that when you do this differentiating, you have to apply the chain rule. And this will give us dA dt here. This will be pi 2r dr dt. And well, that is the relation for the related rates. And we can now go ahead and plug in the given values. the given values. So given values here, everything is up there. So we are looking for dA dt, and this is 2 pi. dr dt is 5, and r is 100. This will give us what? 1,000, 2,000 pi. Why 2,000? Sorry, this is 1,000. 1,000 pi, and the unit, if you want to see what is that, just multiply the units that you have. This will be meter square meter per minute. We are not the units are not important for us, but what we did was we started with that equation and then find the relation for the rate of changes, plugged in the values, and we found how fast the area of this spill grows at the moment that R is 100. It will grow with the rate of 1,000 pi meter square per minute.